Today we're doing the testing for negative ions. The first negative ion we're going to test for is carbonate. So I have my sodium carbonate. So sodium carbonate is Na2, which is the bit we're not interested in, and CO3 2-. So I'm going to put a couple of centimeters cubed of my sodium carbonate into my first test tube. Into the second test tube, I'm going to be putting lime water. As you may remember from the gas tests, the test for carbon dioxide is that it turns lime water cloudy. If we add an acid, so we've got nitric acid, if we add an acid to our carbonate, it should break down into water, salt and carbon dioxide. So the CO3 2-, when combined with two protons, will make water and carbon dioxide. We're using nitric acid because we don't want to contaminate our sample with chlorine from hydrochloric acid, or we don't want to contaminate with sulfates from sulfuric acid. So what we're going to do is going to put our nitric acid in. I can see effervescence now, and I'm going to put a bung on with a delivery tube into the lime water. So that may take some time, so what I'm going to do is I'm going to move that to the side and perform the other tests, and hopefully at the end that will change colour. So the next test that we're going to perform is the halide tests. So testing for the halides, we do the same test for all three halides. So I have some potassium chloride, potassium bromide, and some potassium iodide. And we're going to put roughly the same amount into each test tube. So I'm going to start with the chloride because it's higher on the periodic table. Let's go from chlorine, or chloride rather, to bromide. And finally, potassium iodide. The potassium is a relatively unreactive ion, so will not be involved in the reaction whatsoever. So we are going to add nitric acid. So this nitric acid will help remove any impurities. And again, the reason we use nitric acid is we're not introducing any chlorides and we're not introducing any sulfates. So they don't need a huge amount, but they're all now acidified with nitric acid. And we now have our silver nitrate. So the silver nitrate will react with the halides. So the silver nitrate will actually break down into Ag+, which is silver, and NO3-. The NO3- is not going to take part. The only ion that is going to take part is the Ag+. So when the Ag+, which is aqueous, reacts with the halide, which is also aqueous, we'll get a halide salt. So we'll get silver chloride, silver iodide, or silver bromide, and they will be insoluble. So it's going to be a precipitation reaction. So this was the chloride. This is the bromide. And this is the iodide. So we've got three clear precipitations. So the fact that there is a precipitation tells us that there is a halide present. Our chlorine creates a white precipitate. So our chloride creates a white precipitate. Our bromide makes a cream precipitate. And our iodide makes a yellow precipitate. The iodide and bromide precipitates are difficult to tell apart, but you can see that this is slightly less yellowy than the iodine. The final test for negative ions. So the final test for negative ion is for sulfate. So I have some sodium sulfate. What I'm going to do is add some sodium sulfate into my final test tube. What I'm now going to do again is I'm going to add some acid to remove any impurities. I'm adding nitric acid. Again, if we were to add sulfuric acid at this point, we would get a false positive. So I added my nitric acid to remove impurities, and I now add my barium chloride. And straight away we have a white precipitate. So this white precipitate is the barium ion, which is a Ba2+, is reacting with the SO42-, making BaSO4. It's an insoluble salt, so we've got another precipitation reaction. If we now check our carbonate ion, we have had some bubbles and it is very, very slightly cloudy. I think the concentrations that I've used have produced very, very little CO2, but we can see some clouding, a very, very small amount of clouding, which is a positive test for carbon dioxide. So you know the gas evolved from this is carbon dioxide. It's very important to note that we use nitric acid. Because nitric acid, we are not checking for any nitrate ions, and nitric acid is very good at removing impurities from our solutions. If we were to perform the sulfate test, so if we're adding barium chloride, we would be introducing chloride ions, so we must do the barium reaction before the halide reaction.